So I'm going to give you guys some idea of trigonometric functions using a unit circle. It's going to get a bit wild in here for a second, so pause me if I say stuff that doesn't make any sense at all. Cool? All right, so the first thing we need is a unit circle, which means I need a circle. Eh? Ovals are like circles.
Eggs count.
Blobs are like ovals.
Eggs count.
Should have a circle drawing contest in here someday. All right, so usually there's an x and a y, right? So what's that? Like from previous lives, there's usually x's and y's on two-dimensional pictures. Okay. All right. What's a unit? One. Okay, so what's a one circle?
Circle that has
Probably a circle of radius 1. Okay, so that's going to be 1. That's going to be 1 there. Cool.
your ones look incredibly like twos.
Now you're gonna have to switch the way you write your ones.
I'm not switching the way I write my ones. I already traded my 2's out. It took me all semester to trade my 2's out, all right? Forever. Okay, so here are the two trig functions. First, I need to establish what the inputs are going to be. Okay? So I need to tell you about trig functions in general. And there's 3 that I'm going to talk about right now. And there's sine, cosine, and tangent. Okay? So when you say this, you say sine. When you say cosine, you say cosine. And when you say tangent, you say Steve. No, say tangent.
Steve.
Cool? Got these? All right. You may recognize these from somewhere. Where do you all recognize these from?
My calculator.
Yeah, good. There are buttons on your calculator, right? Okay. So these things are going to start somewhere, right? They're going to have some inputs, and they're going to give you some associated outputs. So does anybody know what the input category of these guys is?
So over adjacent.
Oh, close. That's what it gives you. So what does it start with? What do these things take?
Angles?
Okay, so these take angles. And it should be noted that these two take all angles, sine and cosine. And then tangent takes almost all angles. There's a couple it doesn't know how to work with. And we'll see that on the picture here. You guys okay with this? So first I'm going to give a random angle. All right, here's a random angle. I'm calling it theta, mostly to confuse the bejesus out of you. Sorry about this, it's really just kind of a convention that we use funky letters for angles. Everybody just understands that by that I mean whatever angle, I just want to deal with one to start with. You guys cool with that? I'm just kind of drawing a picture to represent all the angles, all of them. Cool? So here's some random angle. Here's a dot up here, right? That should have some two-dimensional coordinates, right? You guys see that? Okay. So let me rip those two-dimensional coordinates off. I'm going to make them red and blue. I'm going to call this one blue because I like this one better. I'm going to call this one red because I don't like it as much. You guys see that? So there's this little triangle in here, right? It's got a theta in that corner. What's the angle in this corner over here?
Should be right.
It better be a right angle. Why should it better be a right angle? Because this side's parallel to the x-axis and that side's parallel to the
Y-axis.
Y-axis, and all of the geometry we've done so far depends on this being perpendicular. Really, we just defined them to be perpendicular. You guys okay with that? This is really just a definition thing. So I have a right triangle, and the side over here is blue, and is it one long?
No.
No, it's not one long, and that one there is kind of confusing, right? Where else could the one go?
Hypotenuse.
Yeah, it should go on the hypotenuse. You guys all see that? Okay, so I'm going to make a definition for you. And this is going to be the definition of how sine and cosine work. I'm just going to define that blue length to be sine of theta. Whoops, not sine. That would be bad. Let's define the blue length to be cosine, because that would work better. It should be noted that's a totally arbitrary definition. You guys see that? The only reason I just whooped myself and erased it is that your calculators already think cosine is that blue side. If I named that blue side sine, you would be confused because the buttons would be backwards on your calculator. But it's just a vocabulary thing, right? The math doesn't depend on any of that. Cool? How about the other side? The y? What are we going to call that? Sine of theta. Cool? Do you all believe that given an angle, you could draw this circle in the dirt, right? You could measure that angle using a protractor, and then you could measure sine and cosine off of it. You all believe you could do that with a ruler?
In the dirt.
You probably should. That would be kind of awesome. Let's do that in a minute. So, do you all believe that you could kind of halfway do that? That's actually pretty close to the level of sophistication that your calculator uses. It's not quite that dumb. It doesn't have like a little circle inside of it that it measures, but it's close. In a lot of ways, that would be a better calculator. Cool? So,
are you saying cosine is x and sine is y then?
yeah, cosine's the x coordinate to this point, and sine's the y coordinate to that point. You guys all cool with that? All right. Anybody know where I can read tangent off of this thing? Some of you know that it's maybe the ratio between sine and cosine, but I'm not going to define it that way. Do you know where I can read this tangent off? So this is a super cool thing. This took me a while to learn, actually. So here's a line. This line is what we call tangent to the circle. It touches at just one point. And so if I want to read the tangent off, I just pick this distance here. That's tangent of theta. You guys cool with that? Similar triangles will get you to the idea that that's sine over cosine. In fact, we'll do that later. But for right now, I just want you to know it's that distance on the outside.
Why do we want the outside?
It's just a definition. It'll be useful for something. This is one of those things like the perimeter was earlier, right? You could wander around and make all sorts of definitions about this. Some of them would be more useful than others. These are, in my mind, the three most useful ones. But you could draw all sorts of things on this, and people have. There's all sorts of other trig functions that you can read off of this picture, and some of them are useful for stuff. Like navigating using a sextant, for instance. Let's cool with that? Does anybody own a sextant? Okay, so let's stick to these three for a minute. Maybe we'll buy a sextant as a group and then we'll learn to use it. Can you all tell me where the inputs went? So I took an angle, right? What did sine give out as a output? Yeah, it gave a length of the, kind of the opposite side here. You guys see that? And it's going to cause confusion if I just let you know it's a length. So I'm going to tell you it's a ratio. I'm going to tell you it's the red length. And then Ashira knew that this was supposed to be the opposite side over
Adjacent.
over the hypotenuse. So I'm going to divide that red length by 1. Okay, see that? So this thing here, right, is our ratio of lengths. Let's go with that. It also happens to be exactly that red length, right?
So would it just be the line, like the red line over the radius every time?
Yeah, so in practice, right, if you don't have a radius of 1, if you know the sine of an angle, you'll get the opposite side divided by the radius. Cool. So that would be not unit circle approach, right? That would be arbitrary circle approach. Cool. Today we're doing unit circle, but tomorrow we'll do arbitrary circle. Cool. Questions? Thanks. How about where's the cosine function go?
Adjacent over hypotenuse.
Yeah, note that takes you to also a ratio of lengths, right? That one being a slightly different ratio, right? That's the blue length divided by 1. Where's the tangent go? Yeah, this one's going to be harder to see with the setup I've given you.
What did you do? Would you want us to use the black one only, or just do the red over blue?
Perfect. Either one. You guys see that? So this definition doesn't care. We could pick, right? Whatever thing I get here is going to be a ratio of lengths, right? And I could pick either take the black line's length, divide by 1, or I could take the red line divided by the blue line. Those are the same number. Let's go with that. So let me put both of those things here. In some contexts, the red line's length will be nice. In some contexts, the black line's length will be nice. In other contexts, the red over blue will be what we're looking for. Usually, we're going to use red over blue. But we could also use black over blue. And these are the same. And this is still some kind of ratio of lengths. Let's go with that. Somebody tell me the mnemonic that I should be using for memorizing angle goes to what?
Sokotoa.
Perfect. So, toa. Please tell me I spelled that right.
Yeah.
Good? Cool? All right. So, let's call this and we'll practice for a little bit.